Greetings, everyone. Today we're going to talk about solving log equations. Now, we started this a little bit in my basics of log video, but we're going to expand, of course, and take a little more of an in-depth look. The first thing I want to discuss is the real world or a real world application of logs. So even though it seems like we're solving just straight plain old math problems, logs are used in the real world. So specifically when we're talking about the speed of the center of a tornado, and it's related to distance. And so here's an example of an equation that can be used to calculate information. So for example, I'm just going to throw up a couple of pictures here for you. This particular tornado struck Moore, Oklahoma in May of 2013, and it was traveling a distance of approximately 17 miles. That's easy to physically measure on the ground, right? But what's not as easy to measure is maybe the estimated wind speed at, without a bunch of data collectors in the tornado. And so using this formula, we can physically measure the distance on the ground that it traveled. And by plugging in that value, we can calculate the approximate speed. Now, I do want you just to take a moment. This is a common log, so whether you use base 10 or just plain logs, up to you. But we do need our calculators for this lesson. So if you want to pause, get your calculators out, practice typing this in, and just make sure that we're getting the same values. And so the approximate wind speed would be about 179 miles per hour. And you base that on the unit of measurement given. A couple other specific photos from that very tornado. It's just amazing the devastation and how math can be so closely tied to it. And so just a quick refresh. One of our previous lessons, we solved exponentials, right? We solved using common base. So just a quick review this of common bases. If we can get if we can get a common base, right, we were able to just drop the bases and then set the exponents equal to each other. And that lesson went really fast and really well because the solving was easy, right? So I bring back that example and that explanation because just like we dropped the common base, if it is a one-to-one relationship of logs, we also don't need the common log. And so again, it has to be one chunk equal to one chunk, right? If you have plus or minus in there and more than one piece of information, then this isn't true. But if it's one to one and they share the same log base, then we actually can just drop those logs. And so a couple of these problems are going to be so easy to solve because if we cross off the log, we're back to algebra 1. And we just solve our equation. And so I'm going to show as much or as little solving steps as you need. And one thing you want to make sure of, as always when solving equations, is to check your answer. So if I take log base 5, right, if I was to plug it back in, 4 times 4, 16 minus 7 is 9. If I plugged it into the other side, 4 plus 5 is 9. And we can calculate log base 5 of 9, right? And so how are we expanding this? What if I have an equation that doesn't have a common log or a common base such as this? Well, we know how to convert, don't we? We do. We know how to convert. And so let's work on that conversion. And so the base, see my other videos, becomes the base. The answer becomes the exponent. And what's remaining becomes the answer. Remember when we did all those conversions? And so what we did is we took a log question and created an exponential equation that we can calculate and we can get our nice clean answer. Even with these, we could plug it in and use our calculators to make sure we're correct. You've got that log key. So if you're using a scientific, don't forget, use change of base formula, log of 64, close parentheses, divided by log of 2. Or if you're using a graphing calculator and you go to the math function, you can find the spot for that little base. So definitely continue to check your work. So let's keep going with solving similarly. So the base becomes the base, the answer becomes the exponent. So easy to get started, right? So x is 125. Perfect. Okay, the x is in a different spot, but I don't know what it is the way it is. So let's convert and see if that helps. The base becomes the base, the answer becomes the exponent, and we're going to solve a radical. So depending on how you think of this, if you're using a roots chart, you can probably just look at it. Or you could do the opposite of fifth power and do fifth root if you want to straight plug it in your calculator. Or you could do 32 to the 1/5 power. Okay, so just remembering all of those previous exponential and radical conversions. All right. Um, and some of you maybe even have these memorized, right? So let's get our nice clean answer of 2. We could double check, right? Plug that in, make sure that we get 5. Let's throw some expressions in. Not more difficult, we're just remembering our conversion. The base becomes the base, the answer becomes the exponent. What's remaining is my answer, right? And so we're going to have 8 equals easy solving after that. Make sure to check your work. 12 minus 4 would be 8. Log base 2 of 8 is 3. Okay, we've talked about this before, but remember, you need to isolate the function first. You need to rewrite the question in log form. All right, this is natural log, so don't forget, if you need to see your previous notes, that means my base is e. E to the negative third is x. That's a previous lesson. You absolutely need to use your calculator for this, so don't forget. Make sure you use a negative key and not a subtraction sign. And also make sure you use an approximation symbol and 3 or 4 decimals, rounding or truncating, that's up to you. We have to isolate our function. So we need to kick that 3 to the other side. So I'm going to rewrite my problem. Ooh, okay, let's convert this. Because my x is part of my natural log, I need to convert. The base is e. The answer becomes the exponent. All right, now we're going to do some strategic calculator work. I am going to solve this in order first, right? The next thing I would do is divide by 3. I'm going to keep it like this for now. And the next thing I would do is square root. So a strategy could be piece equals piece equals piece. Another strategy could be to try and type it all in at once. If you do that, make sure you use parentheses. Okay. When you type in 1/3 into the exponent, if you use a scientific, you may want parentheses around the 1/3 as well. If you're using a graphing calculator, it should just create that exponent for you. But please take some time, mess with it, calculate it. Now let's talk about solving though. We just square rooted. When you square root, you need to account for the positive and the negative value. Remember that? So let's see if that makes sense. If I go and square a positive, it's going to remain positive times 3 ln times 3. That makes sense. If I take the negative and I square it, I'm still going to get the positive solution, right? So that makes sense. Now, if you can keep that in your calculator, here's how you would check the positive at least. We're just going to straight type in 3 natural log of 3 times answer squared. If you can type that in with the previous answer, that's how you get the 1 and you know you're on the right track. But don't forget negative. Maybe put a star there. When you square root, you need positive, negative. Oop, we have 2 logs. We have a 1-to-1 relationship. So you have to be observant. Do you have 1 log and you need to convert? Or do you have 2 logs and you get to drop? You have to know the difference. Show as much or as little work as you need and always check your answer. Now, believe it or not, this is a one-to-one relationship. I have one log. Yep, that's one log because it's contained in parentheses, equal to one log. So yes, we get to drop our logs. Okay, so if I rewrite my leftovers, look at what we have here. Now, there are multiple ways to solve this. I'm going to be honest, I'm going to show you the longer way because I want to have a conversation about it. If you see a shorter way, feel free to ignore what I'm writing and solve what you see, okay? I'm going to show the longer way, or maybe the robot way that we've sort of programmed you to be, and that would be to FOIL that left side, and then to move everything to one side, and then to factor, and then to solve. Okay. Now, I showed the longer way because it's what most students will typically do, but also because I need a specific conversation. So if you solved another way, you maybe only got one answer, but can we talk about these answers if I go to check these? This is very important. If I checked log base 3 right here, and if I plugged in my x of 3 minus 3, that would be like saying log base 3 of 0. Is there any power, right? Let's think for a second. Is there any power of 3 that can get me to 0? Is there? There's not. There isn't. So if you know your conversions, it doesn't make sense. Or take a moment actually and try typing this into your calculator. I get an error domain, or your scientific might say something else. And do you know why? You cannot take the log of 0, which means this solution is extraneous. We can't use it. Now, if I check 5, well, 5 minus 3 is 2. That works. And if I put 5 into the left side, that'd be 1 times 2, which is still 2, and it would work. So we're good to go with the 5. So maybe make some kind of note. Can't take log base of 0. It's not okay. It doesn't work. All right, I have a single log, so I'm going to convert to base, answer exponent. Right, if you memorized that conversion, this stuff goes so fast. So 2 to the 5th, and we're going to minus 7, and we're going to divide by 5. I mean, some of you are so confident that you'll probably just solve and get your answer. All right, let's try this again. I have a single log, so I'm going to convert to exponential. Base, answer exponent. Oh man, we have a quadratic, which means this 27 needs to get kicked to the other side. And once it's on the other side, we're going to need to factor. And that's going to get me 2 solutions. Oops, I meant to write x equals. X is going to be 9 or negative 3. Okay, we need to check these answers though, okay? If I go to plug in 9 squared 81, 9 times 6 subtracted from 81. I'm just going to convert that right away. So we're saying log base 3 of 27 is 3. Yeah, 3 to the 3rd is 27. That makes sense. 9 is good to go. Okay. Let's also check negative 3. Okay. The quantity negative 3 squared minus 6 times negative 3. Negative 3 squared is positive 9. Negative 6 times negative 3 is positive 12. So that gets me to 20. Oh my gosh, I can add today. 21. Oops, what did I do wrong here? 6, 12, 18, not 12, more than that, 18. I was like, why am I not getting 27? All right, 27. Okay, we still got positive 27. So wait, I can have 2 correct answers. Now, a lot of students look and say, wait, we can't take the log of a negative. Well, when I plugged it in, the double negatives went away. They became positive, right? So a negative is not automatically a bad, but you do have to remember that if for some chance we gave you a problem and you had just -3 by itself, that can't work, right? Again, practice typing that in your calculator. You're going to get non-real answers. Why? Because square rooting would get you imaginary, da 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 da. Okay, so far, maybe add a little note to the side, just like we did previously. We can't take the log base of a negative. Not okay. But if the negative cancels within the work, that's okay. Again, I put this slide in here just to reiterate. We can't, there's a negative. We can't, it's 0. It doesn't work. It's so hard to miss though because it's going to look like the math works. It's the log that makes it different. So don't forget, you can't take the log of a negative or 0. All right, that's our examples. This lesson was so many examples, but we wanted to cover all of our bases. Make sure you check out Google Classroom. Make sure you memorize that conversion. Log to exponential, exponential to log. So important, okay? Make sure to ask all the questions, seek help in the Sabre Center, and until next time, have a good one.